Good morning to all of you, and you're welcome to the Chopra's School of Physics. In the earlier classes, we have discussed about the capacitance, potential, Coulomb's law, and we have correlated them along with their formula. Now, we have to go through with a basic idea of permittivity and permeability. These two ideas you will get for the various questions to estimate dielectric constant and what is the importance of dielectric constant. But before that, you must also know what is electrical potential energy. When we use this term electrical potential energy, mathematically, electrical potential energy is nothing, basically it is the work done. So electrical potential energy is the work done to bring a charge from infinity to a point in the field. So some work is done to bring a charge. So you will remember, electrical potential energy, that is represented by EP. This is the symbol for electrical potential energy, and it is basically work done, and work done is force multiplied by distance. So here EP stands for electrical potential energy, W stands for work done to bring the charge, F is the electrical force between the two charges in the field, and R is the distance between the two charges in the field. Now, we can write this formula as K Q1 Q2 divided by R square. This I have put the formula of Coulomb's law, multiplied by R. R cancels off and the formula will become K Q1 Q2 divided by R. So what is the difference between electrical potential energy and the Coulomb's law? In the Coulomb's law, in the denominator, it is R square. But when we speak of electrical potential energy, it is the computation of Coulomb's law multiplied by R. R will cancel off and R is supposed to be the linear function. So electrical potential energy is K Q1 Q2 divided by R. Here in this case, these charges are taken in Coulomb, R in meter. You are using K here. It means we are adopting the MKS convention. And EP will be estimated in joule. So whether you calculate electrical potential energy or the work done, the unit is joule. So joule will be equal to Q1 Q2 divided by R. Wherever we have to estimate electrical potential energy or work done, that will be this one. Joule is MKS unit of EP or work done. EP means electrical potential energy. So electrical potential energy, the unit is joule in MKS, but in CGS units, it should be ergs. And 1 joule is 10 to the power 7 ergs. This is not given in the examination. This is, you are supposed to remember this well. And 1 erg is 10 to the power minus 7 joules. So this concept is clear to you. This is all about electrical potential energy. And now we are further proceeding with permittivity. Permittivity. And other term frequently used, permeability. permeability. You'll further remember that permittivity is an electrical phenomenon. Electrical phenomenon. And permeability is a magnetic phenomenon. Magnetic phenomena. And when we use both electrical and magnetic phenomena, if we combine these two phenomena, that is becoming electromagnetic phenomena. Electromagnetic phenomena. Like normally we read electromagnetic waves, so we have to use both the phenomena. So you will now remember permittivity, that is symbol is epsilon, epsilon naught and epsilon r. This is called permittivity. This is called absolute permittivity. And this third one is known as relative permittivity. Relative permittivity or dielectric constant. DEC. DEC stands for dielectric constant. The other name SIC, specific inductive capacity. So the point to remember, epsilon r stands for relative permittivity, the dielectric constant or specific inductive capacitance. And the symbol absolute permittivity. And this is simply permittivity. Now we have to relate them. The formula permittivity is absolute multiplied relative permittivity. So you will now remember permittivity is the product of absolute and relative permittivity. And relative permittivity is the ratio of permittivity and absolute permittivity. So I have written dielectric constant here. Dielectric constant. What is the other name? Specific inductive capacity, or it is relative permittivity. So relative permittivity or dielectric constant is the ratio of permittivity and absolute permittivity. Now our question arises, what is the unit of dielectric constant? Now you have to make a recollection. Permittivity, this is expressed in Farad per meter or Coulomb square per Newton meter square. And absolute permittivity, that also has the same units. So it means whatever is the unit of this, the same is the unit for this, both units will cancel off. So dielectric constant has no units. It is a dimensionless constant. So it has no units, and relative permittivity is dimensionless constant. You will further remember that when we use the term relative, there must be some base number. Relative to what? For example, 5 is a big number. But 5 is a small number also. 5 is a big number with respect to 4. So relativity of 5 to be big is 4. And relativity of 5 to be small is 6. It means that big or small is a relative number. We will say 5 is bigger than 4, so relativity is 4. 5 is a smaller number, that is with respect to 6. It means that this relative permittivity, it is always calculated with respect to absolute permittivity. So point to remember, relative number always estimated with respect to absolute number. But absolute number remains constant. It does not change. So you remember, absolute permittivity of different mediums will be different. Absolute permittivity of different mediums will be different. If absolute number of the medium will change, the relative number will also change. So what is the point to remember? Relative permittivity calculated with respect to absolute permittivity. If epsilon naught changes, epsilon r will also change, will also change. Epsilon r calculated with respect to epsilon naught. If epsilon naught changes, epsilon r will also change, and epsilon naught for different mediums, will be different. Epsilon naught for different mediums will be different. And we have written, if epsilon naught changes, epsilon r will also change. Dielectric will also change. So epsilon naught for different mediums will be different. Therefore, epsilon r for different mediums will be different. So why different mediums have different dielectric? The different mediums have different dielectric because the different mediums have different absolute permittivities. Absolute permittivity is a fundamental concept of a particular medium, whether it can conduct more electrical lines of forces or less electrical lines of forces. So we are not deeply going into it, we are simply remembering this formula, and this is about the conceptual point to remember, that dielectrics are calculated with respect to absolute permittivities, and absolute permittivities, and if absolute number changes, the dielectric will also change. And absolute permittivity for different mediums will be different. Therefore, epsilon r for the different mediums will be different. So I hope that this concept is clear to you. Now, we have to further elaborate this concept to be applied in the calculations. Mainly Coulomb's law, as I have explained you, written as like this: 1 over 4 pi epsilon naught epsilon r. Now this is a more elaborate form of the Coulomb's law. Q1, Q2 divided by r square. Now we will say that for air medium, relative permittivity of air, that is 1, with respect to absolute permittivity of air. And absolute permittivity of air is 8.854 into 10 to the power minus 12 Coulomb square per Newton meter square. Now in this equation, if epsilon r is taken as 1, it means we are finding the force in air medium between the two charges. So, if we say epsilon r is 1, what is the meaning of this? The meaning of this is that both the charges are kept in air medium. So, for medium, that is more elaborately we should write for air medium or vacuum. I have explained to you that there is a common term for air or vacuum, that is free space. So relative permittivity of air is 1 with respect to absolute, and absolute is this one. So if we compute epsilon or 1, the formula will become force in air medium. Instead of F, we should write Fa. So force in air medium. Now 1 over 4 pi epsilon naught we will write 1 over 4 pi epsilon naught. And epsilon r, that is 1. And if 1 is multiplied by any number, it will remain that number. So we will write Q1, Q2 divided by r square. Now this formula is for air or vacuum, and this is the general formula to be applied to any medium. Any medium. So this formula is applied to any medium. This formula is applied to air or vacuum. How we got it? This is the concept. This is to be remembered, that dielectric of air is 1 with respect to absolute, and that is the absolute value. So here relative number is computed as 1. The formula will reduce to 1 by 4 pi epsilon naught into Q1 Q2 by r square. And this number we have already calculated. 9 into 10 to the power 9. That is K. So this number is generally taken as K multiplied Q1 Q2 divided by r square. And K is 1 over 4 pi epsilon naught. In any calculation where we write K, K will be taken as 1 over 4 pi epsilon naught 9 into 10 to the power 9. Units, I have already explained you, Newton meter square per Coulomb square. So this is how we use dielectric constant. So absolute permittivity and relative permittivity, this product gives permittivity. Now see the formula, epsilon naught, epsilon r. We can replace this number by epsilon. So what is the general formula of electrical force? The general formula of electrical force is, now see here, so we can write 1 over 4 pi epsilon Q1 Q2 divided by r square. Force is inversely proportional to epsilon. So now you remember, what is the relation of force with permittivity? We are finding epsilon. That is, if permittivity is more, force will be less between the two charges. If permittivity will be less, force will be more. So if permittivity is less, force will be more. And if permittivity is more, force will be less. The upward arrow makes increasing, downward arrow decreasing. So permittivity will be less, means force is more. Permittivity more means force is less. So between the two charges, which medium is existing, that's more important. So this is all the application of permittivity. This is the formula. Dielectric has no units, that you will remember, and dimensionless constant. So these are the facts to be remembered for permittivity, and other concept is regarding permeability. And you will remember that if you wanted to estimate the dielectric of different mediums, then we must have a formula for the different mediums, that is dielectric of medium. 10 to the power 12 over 8.854 multiplied absolute permittivity of the medium. So I have written a formula to be applied for any medium, that is dielectric of a medium, 10 to the power 12 by 8.854 into absolute permittivity of that medium. This indicates that if absolute number will increase, the dielectric will increase. If absolute number will decrease, the dielectric will decrease. So I hope this concept of permittivity is clear to you, and now we'll take a few more moments for discussing permeability. Regarding permeability, you will remember that permeability is represented by mu, then absolute permeability, and then the relative permeability. So now, like permittivity, there are three types of this permeabilities. This is simply known as permeability. The second one, absolute permeability. And the third one, the relative permeability. And mu is equal to mu naught multiplied by mu r, and mu r, that is mu divided by mu naught. So wherever we have to estimate relative permeability, it should be the ratio of permeability and absolute permeability. You will further remember that relative permeability of air, that is one, with respect to absolute permeability of air, and absolute permeability of air, 4 pi 10 to the power minus 7 Henry per meter. The alternative unit, Weber per ampere meter. That is the same thing. 1 Henry will be equal to 1 Weber per ampere. Henry is the unit of inductance, unit of inductance. Weber is a unit of magnetic flux, and flux is written as phi. That's the symbol of flux. And ampere. This is current. 1 Henry is 1 Weber over 1 ampere. This is current. 1 ampere. Current is the unit of, or for current the unit is ampere. And you will further remember that in case of Henry, the current must be alternating current. It should be alternating current. A stands for alternating. Alternating current. This is the graph of alternating current, and this is the graph of direct current. This is alternating current. This is a pattern. We will discuss more about the alternating current in a separate chapter. So these are various formulas I have explained to you, and dielectric is like this, and this is the ratio here, and you will remember that for mu and mu naught, the unit will be either Henry per meter or Weber per ampere meter. And 1 Henry will be equal to that is equal to 1 Weber over 1 ampere. Henry is a unit of inductance as I have written, and inductance is represented by L. So this is a general formula or general representation. Flux represented by phi, current represented by I. So we got the formula of inductance. Inductance is defined as magnetic flux per unit current. Magnetic flux per unit current. L is phi over I. You remember L stands for inductance, phi stands for Weber, I stands for current. Like here we have read the general formula of dielectric. You will further remember that relative permittivity is 10 to the power 7 over 4 pi multiplied by absolute permittivity of medium. So relative permittivity of medium, permeability of medium, this one, and this is absolute permeability of medium. If you combine permittivities and permeabilities, we come to a general formula of the velocity of light, velocity of electromagnetic wave. So you will remember that both the concepts combined to get the velocity of light. Velocity of light is taken as c 1 over square root of epsilon naught multiplied mu naught. So you will now remember that c stands for velocity of light, and velocity of light is calculated by both the numbers, absolute permittivity and absolute permeability. This velocity of light will become 3 multiplied by 10 to the power 8 meters per second, or 300 multiplied by 10 to the power 6, like this, meters per second. We will read as 300 million meters per second. 300 million. So this number is written like this. 8 is made 6, 2 zeros here. So it is read as 300 million meters per second. This is the velocity of light, and this is in air medium or vacuum. If medium will change, these two numbers will change. And if both these numbers will change, the velocity of light will also change. So velocity of light is never constant. It varies according to medium. And how we got this number? By taking both the numbers for air medium. That is, if you take epsilon naught as 8.854 10 to the power minus 12 and mu naught 4 pi 10 to the power minus 7. If you take these two numbers, mu naught and epsilon naught, if you take both the values here, you will get this particular number. The unit of this number and the unit of this, both the numbers here, that will be velocity of light in air medium. And light is electromagnetic wave. So you will remember when we write EMW, it is electromagnetic wave. C is velocity of light, and light is what? Electromagnetic wave. So what is the formula for velocity of electromagnetic wave? Velocity of light or velocity of electromagnetic wave, 1 over square root of epsilon naught into mu naught. Absolute permittivity of air medium, and this is absolute permeability of air medium. So this is how we estimate the velocity of light or the velocity of electromagnetic waves, And this formula which I have written, this formula, this is called Maxwell equation. Maxwell equation. I hope you will remember all these concepts, and in our next classes we are going to have the application of all these things. Thank you very much.